All right, let's take a look at this example because I want to show you another little trick when it comes to factoring. Okay. Now, we've already talked about one trick where we have to make sure that if there's no common factor up here, we can't have common factors in the binomial factors later on. But there's another trick. And the trick comes from you writing out your factor pairs for your lead coefficient and your constant term, always. So 4 can break down as 1 times 4 or 2 times 2. 7 is prime, so it can only be 1 times 7. Is that okay? Now here's where the next piece of logic comes in. 2 and 2 have a common factor, don't they? What's their common factor?
2.
Here's what I'm going to do with the common factor.
1.
Does 2 go into 16 evenly?
Mm-hmm.
If you have a factor pair that has a common factor, check to see if it goes into the middle term evenly. If it does, then you should use it. If this had been a 15x instead, does 2 go into 15 evenly? No, and so you would not have used that guy.
2 goes into 2.
Huh?
4 goes into 16 too.
But that's not. What's the common factor for 1 and 4? 1. Right? The common factor for 1 and 4 is 1, and that's always going to work. You want to find factor pairs that have a common factor that's higher than 1, like a 2. Okay? So what this tells me is that I should use this guy. So that when I factor this, I'm not going to start with 4 and 1. I'm going to start with 2x times 2x. What do you know about your signs for the positive 7?
Positive.
They're both positive. So I've got to use the 1 and the 7. Should I put the 7 with the 2x or the 7 with the 2x?
Doesn't matter.
Doesn't matter, does it? So 7 and 1. Now this is why the logic comes into play. Common factor is 2, right? Notice that whenever I do the inside piece, I get 14x. The outside piece is a 2x. Do y'all agree? Mm-hmm. Notice how this guy's a multiple of 2, and this guy's also a multiple of 2. If you add multiples of the same number, it'll be a multiple of that number. So if this, if we had something that was, say, 5 and 5, like if this was 25, 25 could be 5 times 5, but does 5 go into 16? No, because if you had 5s here, you'd have a multiple of 5 and a multiple of 5, and the whole thing would have to be a multiple of 5 when you add those guys. But if the middle guy isn't a multiple of that number, you can't use it. That's why here, since this common factor was a 2, I know that the outside and inside will be a multiple of that factor, and 16 is a multiple of 2. In other words, 2 goes into 16 evenly. So there's my positive 16x, so everything checks out okay here. Let's see this again in the next example. If I try 8x squared minus 34x minus 9. I want us to list all of the factors we have for the lead coefficient and for the constant term.
2 and 4, 1 and 8.
Right, so 1 and 8, 2 and 4. What about 9?
3 and 3, 1 and
1 and 9 and 3 and 3. Do y'all agree?
1. Mm-hmm.
Are there factor pairs that have a common factor other than 1?
No.
Look again.
Sorry?
3.
What are you asking? I mean,
Are there factor pairs up here, what I listed in blue, that have a common factor other than 1? 2 and 4 have a common factor of what?
2.
I thought
2.
you're asking if there was the numbers of factors that were common, what the coefficient and the constant number.
No. You look at them individually.
Sorry.
So here, does 2 go into 34 evenly?
Yeah.
So that means I should probably use that guy when I factor the 8. Now you also called out 3 and 3. They have a common factor of what?
3.
Of
3.
the common factor of 3 and 3 is 3, right? Does 3 go into 34 evenly?
No.
No. Since it doesn't go in there evenly, you can't use that. That means it's never going to work. Because if you tried using 3 and 3, when you did the outside and inside pieces, that number would have to be a multiple of 3, but 34 isn't. So let's see if I can get help here. So you're saying that I'm going to use, or I'm saying we're going to use 2x and 4x. Do you all agree? Now, I have a negative 9, so what do I know about the signs? One's positive and one's negative. Now, I can't use the 3 and the 3, right? We already said that's wrong. I've got to use 1 and 9. You want to put the 9 here? Well, let's think about this. Suppose you didn't. Suppose you did 1 and 9 like this. You get 4 and negative 18 on the outside. Will 4 and negative 18 give you 34?
36 minus -2.
No, so that doesn't make any sense. Well, hold on with what you're saying there. If I do 9 and 2 like, let's do 9 and 1 like this. Check inside and outside. What do we get? I get positive 36x. What's on the outside? And altogether I get positive 34x. What was I supposed to have? Right. Now, what you see is that we have the right number but the wrong sign. This is not a situation where we freak out. What we do is we don't touch any number. Don't move any numbers around. You've got the right number but the wrong sign. So if I just flip these signs around,
Make the other one negative.
right, if I say this is a negative 9 and make this a positive 1, then when I do the inside piece, I get negative 36x, and the outside is a positive 2x. And so I get a negative 34x altogether. Yes?
I guess I get how you're going about the problem, but where you circle where it says 2 times 4 and then you come out with a 2 and then 3 times 3.
Right.
I don't understand what you're doing there. I get that 2 goes into
The
34.
The logic says these guys have a common factor of 2, right?
Yeah.
Okay. So when I do the inside here and I get negative 36x, that's a multiple of 2. The outside gives me a positive 2x, which is also a multiple of 2.
Yeah.
When you add multiples of the same number, you get multiples of that number. So a multiple of 2 with a multiple of 2, when I add these guys, gives me a multiple of 2. That's what 34 is. Had I used 3 and 3,
Instead of 9 and 1.
right, then that means that whatever numbers I had here, okay, if we just kind of sketch that out on the side. If I use 3 and 3, it doesn't even matter what this is. If I call this A and this is B, and regardless of the signs, I don't care. Inside here is 3B. Outside is 3A. It doesn't matter what this number is. It's going to be 3 times something else, which means it would be a multiple of 3. But since 34 wasn't a multiple of 3, I couldn't use numbers that would give me a multiple of 3.
Okay, so basically we just have to make sure that whatever numbers we use, they have to go into the middle number.
That the common factor goes into the middle number. Because see, 4 doesn't go into 34 evenly. But I'm looking at 2 and 4 together. Their common factor is 2. And 2 goes into 34 evenly. Right. Let's try another one.
Right.
Yep.
So that just basically eliminates the guessing and inserting all day.
Right.
As far as you're finding 2 factors that will both work for the middle term.
Right, so this guy didn't work, was never going to work. I never needed to touch him or use him. This guy gave me something that was going to work, so I'm going to focus my energy on using him. Okay? Let's try this one. 4x squared minus 25x plus 25. Let's make a list of our factors. Let me box this last guy, sorry about that. What are your factors for 4?
4 times 1, 2 times 2.
1 and 4, 2 and 2. What about 25?
5 and 1.
Are there any factor pairs that have a common factor?
2 and 2 and 5 and 5.
2 and 2 have a common factor of what?
2.
2. Does 2 go into 25?
No.
So if I used these guys, that middle term would have to be a multiple of 2, but that's not. So I cannot use that guy, ever. Don't use him. Here I got 5 and 5, you guys were saying.
Mhm.
What's their common factor?
5.
Does 5 go into 25?
Yes.
Then maybe I should try to use him. So when I factor this, it's not as much guessing and checking as it once was. I know that 25 breaks down as 5 times 5 with what signs?
Negatives.
2 negatives. Now 4x squared, I said I can't use 2 and 2, so I have to use what?
1.
1x and 4x, do y'all agree?
Mhm.
How does that work out?
Negative 20x
Negative 20x
minus
minus 5x, and there's my negative 25x that I was looking for. So it checks out.
So either one side or the other has to check out.
No.
They both can.
They could both check out. Like if this had been something that would go in here and that goes in there, then that tells you exactly what combinations to use.
So if it was 15, if it was 15x squared minus 25x plus 25.
Well, 15x squared wouldn't give you any help over here. Because if it was 15, it'd be 1 and 15 or 3 and 5.
No,
But
it'll work.
then 5 would go into 25.
Doesn't, but 3 and 5 as a factor pair, their common factor is 1. It doesn't give us any help. Does that make sense? You understand what I'm saying? You're saying if I had like 15x squared minus 25x plus 25.
Yeah.
The factors here are 1 and 15 or 3 and 5. None of these guys have a common factor other than 1, so I get no help. I don't care that 5 goes in there. That doesn't mean anything to me. The common factor here is 1. 1 goes in there, so it's a viable possibility. I'm looking for those guys where the common factor is something other than 1, and does that go into the middle term? You can't just say, oh, 5 goes in there.
But it's both.
So it doesn't matter. Like here, does 4 go into 25? No, but I used it. What matters is checking about the common factor that these guys share. And does that go in there?
If not, go to the other one, right?
Right. Now, let's put some problems on the board and see what you guys can do with them.